Right, now this question uses the words prove algebraically. So therefore we're going to have to look at the information, decide what it's telling us, and see how we can then manipulate it to prove that we have got a tangent. So if we just sketch a picture to get a feel for what's going on, we can see that this is about a circle, and it's asking us to show that there's a tangent point. So this straight line has an equation of take the 2y across as positive, take the 10 across as negative. So we end up with y is equal to, that goes across as 2y, half it is 5, so it's going to be a half x, take away 5. The circle is centered at 0, 0, and a half x take away 5 means it's going to be doing something like, it's positive. Right. So it wants us to show that it touches that point at one point only. So basically, if tangent, then line must touch circle at one point only, because that's the definition of a tangent. It meets a radius at 90 degrees. So it only touches the circle at that one point. So that's basically what they want us to prove. So what we need to do then is we need to manipulate these two equations to show that there's only one solution, and that solution is at that point. So it means we're going to have to solve two equations simultaneously. So we've got a quadratic form and a linear form, and when you've got that, it's about substitution. So we've already rearranged that to be y equals. We could make it easier to say this one's x equals, actually, because then we keep the numbers as nice integers rather than dealing with halves. So we'll make this one x is equal to 2y plus 10, and then basically we substitute in here. So if we substitute in there, then we end up with 2y plus 10 all squared plus y squared is going to equal 20. And what we're trying to do then is we're trying to show that y has only one answer. And if y's got one answer, then x will have one answer. And therefore there'll just be one point on the circumference where the two lines meet, the curve and the straight line. So therefore it must have been a tangent at that point. So let's have a look. We're expanding two brackets, so 4y squared, 2y, so that's 20, but that'll give us 40y, and then we've got 100, and then we're adding y squared, and that gives us 20, so we end up with 5y squared plus 40y. We're going to take away the 20 to make that 0, so that's going to be plus 80, that equals 0. All of those divide by 5, so let's make the quadratic a bit simpler to work with. So y squared plus 8y plus 16 equals 0. Is that right? Divide by 5, divide by 5, divide by 5. And then we look at this. Now if there's only going to be one solution, it would seem sensible that this would factorise. If it doesn't factorise, we could always use the formula or complete the square on it, whichever method you like. So let's have a look. 8y 16, 4. Yeah, so it looks like it's going to be y plus 4 all squared equals 0. Okay, because we can see that y squared, 4y is doubled is 8y, and then 4 squared is 16. So this tells me then there is only one solution. So one solution, y equals negative 4. Therefore, only one x solution, and that comes from x equals 2y plus 10. So x is equal to 2 lots of negative 4 plus 10, which equals negative 8 plus 10 is 2. So basically then we have therefore one coordinate where the line meets the curve, and that coordinate is 2, negative 4. So one coordinate where the line meets the curve, so it must be a tangent. Okay, so if we go through the logic then. So this question talks about proving algebraically, so we'd have to do some algebra work somewhere, and if we sketch out a picture we can see what roughly they're talking about, and they're telling us to prove that it's a tangent. So if that's a tangent, then it must meet the curve at one point only. So we needed to work out those coordinates. therefore we have two equations to work out the x and y values at points the circumference, and we can manipulate those by solving them simultaneously. And if we show that we've got one coordinate only from this solution, then it proves the point. And by manipulation we can see that we do end up with one coordinate, and therefore it must be a tangent at that point.